Humans use antibiotics for a ton of things. And of course, we use them for our own illnesses. Back in the day, antibiotics were such a blessing that folks, if you got a cold, they would give you antibiotics and be like, well, these might help. And antibiotics don't work on viral infections. So there's a large portion of colds, flus that don't respond to antibiotics. You don't get better. But anything bacterial, not anything, many bacterial infections will respond to antibiotics that we have. And glory days, and it happens fast and it's impressive. We also use antibiotics on our farm animals, and they not only get injected or put into the food of the farm animals, like the cows, then the cows actually pee it out. In fact, back in World War II, when penicillin was first made, it was difficult to produce, such that they would penicillin will get removed from your body through your kidneys. So you actually pee it out when you dose yourself with penicillin. And then so much of the penicillin was getting peed out by people who were using it that they actually collected the urine and purified the urine to remove the penicillin so they could use it again. Cows that get treated by antibiotics will pee out a bunch of antibiotic, and that goes into our water supply. And then there's antibiotics in our water supply, or there's antibiotics in our soil, and it's killing the various bacteria. When you take antibiotics, you impact instantaneously, you impact your microbiome and the bacteria that are living in all of your places, in your mouth, in your gut, in your vagina, in all your other nooks and crannies that have places that bacteria like to live, which are everywhere because, right, we have 3 pounds of them on and in us. So what's the problem with this? What is a potential issue related to evolution? It's antibiotic resistance. And there's 2 lessons here. Number 1, don't take antibiotics unless you know you have a bacterial infection that will respond to antibiotics. That's lesson number 1. Lesson number 2, finish your antibiotics. If you take them, how many of you have done this? You start taking a dose, you have a 10-day dose of antibiotics, and you start taking them, and on day 2, you're like, I'm feeling so much better. I don't need these drugs anymore. And then you stop taking them. You are not helping the scene, the world of antibiotic resistance. So just like any other critter group, a pathogenic bacterial crew that has infected you has variation. They're all the same species, but they're genetically variable. And genetic variability, we know, is beneficial to survival. The example I've got up here for you, a visual of bacteria, and I've tried to illustrate their genetic diversity by showing you different colors. But these are all the same species. These are the bacteria that have infected you when you get sick. And then you start a round of antibiotics. So after 1 day, look at this really carefully. After 1 day of taking the antibiotic, look at the weakest bacteria were the yellow bacteria. They actually got killed on day 1 by the antibiotic, which is awesome. You probably at this point are starting to feel better than you were because you cut the bacterial population in half. On day 2, who disappeared? Another population, all the green ones. I don't know if you saw that they were all green, but now the green ones on day 2 have been killed. Day 1, we got rid of the variation that I illustrated them as yellow. Day 2, they were a little tougher. The green ones made it through the first day, but After 2 days of being exposed, they're game overed. What do you think? Who's going to disappear on day 3? Looks like the purple ones disappeared on day 3. So they had some chops, some genetic skills that allowed them to survive 3 days with the antibiotic, and then they couldn't hang. Our blue ones, our orange ones, and our red one, they're actually still going. They're like, this is cool. Go ahead, show me your best stuff. Day 4, the blue ones are like, wah, wah, wah. Was that the blue ones or was it purple? It was blue. The blue ones. Bye, guys. After day 4, they couldn't hang anymore. But now we have only orange and red ones remaining. And day 5, they're kind of tough. So if you're like, dude, I'm feeling so much better, because right, you almost have solved the bacterial problem, but not entirely. Who's going to live to reproduce if you stop taking your antibiotics right now at day 5? These guys who survived that long, you selected the guys that can make it for 5 days. Okay, day 6, good job. You kept taking your antibiotics. All of them are gone but one. And what's true about this one bacterium, and I say one, but obviously that is a million or whatever, like it's a ridiculous number that haven't been killed by the antibiotic by day 6 or 7. Finally, on day 8, this guy's going, maybe I should be a little bit concerned right now. And finally, after day 9, he's done. What if you had stopped at day 8 because you're feeling so much better? That's the one that is going to reproduce and make more and infect other people. And the antibiotics, we just made through natural selection, we made the bacteria stronger. This is antibiotic resistance. If that red one didn't die and survived, that means that that particular antibiotic is no longer effective against that guy, who now has a free environment, can reproduce like mad. Nothing is going to bother it. It can just flourish and pass to other humans or cows or whatever. So, bottom line, finish your antibiotics and be thoughtful about when you use them. Don't use them frivolously, because we don't have a forever, because of evolution and natural selection, we don't have forever access. We're always looking for new antibiotics that will continue to be effective, because if we can't treat conditions with our antibiotics, we're in deep doo-doo. Okay, finish your antibiotics.